Right. So we just learned in the previous lesson, right? What was a relation? And it was a bunch of ordered pairs together, right? An X with a Y. And we talked a little bit about domain and range and how to get that domain and range from looking at the ordered pairs as well as looking at the graph. And then we also went one step further and determined when is a relation also a function. And the main idea is that if you have a relation, you cannot have an x value pointing to more than one y value. That's the basic idea, right? If you want something to be a function, there can only be one arrow from an x value to one y value. You could have another x value down here pointing to the same y value, that's fine, but there cannot be two arrows going out of one x value, okay? So there it is. So we're going to talk a little bit about functions, how they work, and in a sense, when we look at a function as a machine, right? Something comes in to the machine that's called the input, uh, and then something will be happening to it. That's your function, and then something comes out, right? So since each x value is allowed to only have one y value in a function, that is, we can think of a function as an input and output scenario. So x there, y there, machine. We put x values into the machine, and the machine operates on the x values, does something to it, right? And something new comes out, the y value, the output, right? So for example, if you plug in the 3 and you get a 4 out, well, what happened, right? There was an operation or something done to that input and it was adding 1, right? You get 4. Here you have 3 and you get a 4 and a 2 out of that one. How does that work, right? Is that even possible? If you think about it, if you plug in the 3 and something is done to the 3, there's only, right, there should only be one answer, because let's say it's plus 1, you get 4. How can you get 2 out of that, right? So this is not a function. It would be as if you had your x values here, you have your y values there, right? It's pointing to more than one y value. So this is not a function, okay? So in general, we say that y is equal to f of x, right? So this is going to be our dependent variable, and also known as output. We will sometimes refer to it as that represents the output. This is the function operating on x, right? This is the function. There will be something that will operate on x, on the x value you plug in. And this is your independent variable. And also, as we already learned, that's our input. Okay, so you will see how that works in a bit, right? So just have to have your terminology figured out. Note, f is a function operator, but f of x is the output. So it's the same as y. Okay? So a two-variable equation can be written in function notation. So y is and remember, this is the same in pre-cal and the same in applied if you move forward, right? Y is equal to 2x plus 4 can also be written in functional notation. And that is, of course, provided this is a function, okay? We will later on do a test, actually, but If you were to just ask to rewrite this in function notation, instead of the y, you write down f of x, right? What would you get if you plug in an x value is 2x plus 4. Okay, same thing. We just substitute y, we put f of x instead of y because they're actually the same thing. Okay, so here we go. So the function, right, defined by multiplying whatever x value you plug in, you will be multiplying it by 2, and then you'll be subtracting 1 from it. You have to perform BEDMAS, right? And so if you had a -3, if this is your x, right, and this is your function inside here, what is your f of x or y? Right? That's the question here. So this is how we write it in actual using the proper notation. If -3 is what you plug in, then this x is replaced by -3. So this is saying that the function that you're about to see, we're gonna put -3 into that function. So that's what this is saying. So f of -3 is going to be 2 times -3, because that's what 2x is saying, right? Whatever x is, you're going to multiply it by 2. And so in this case, x is -3. And so it's 2 times -3 minus 1. So we can just go equals here. This is 2 times -3 is -6 minus 1. And so that ends up being -7. Okay. F of x, f of -3 is equal to -7. So you can also say, therefore, y is equal to -7. Okay, you can say the same thing. So here we're performing the actual operation using x is equal to -3, right? And the question mark, what is y or f of x, you can use them interchangeably, is this. Now, I want to tell you something else, like foreshadowing into the future. What you just found, you will find that this is actually the equation of a line that you're going to be graphing later. You found that when x is equal to -3, comma, y is equal to -7. Okay, that's what you found, and this is going to be a point, -3, -7 is a point on the line. And right now, if this is like, what's happening here, don't worry about it too much. Just focus on knowing how to do the operations here, okay? Because it's going to change, as you can tell already, right? It's going to get challenging. So let's do, and by the way, f of x is the most common notation there is. However, it doesn't have to be f of x. It could be g of x. It could be h of x. It doesn't matter. What you need to know is that when you see a letter of x or something like this written like that, that is our y. That's our, it's gonna, you can replace it with a y if you'd like. And the independent variable is going to be on the other side. Okay, so let's try it here. G of h. This is given the way it's written, that is technically our independent. So this is h right here. This is g, the function. And what you would get here is g of h. Or we could say y as well, but we're just going to keep it like that for now. H is equal to 2, so we just substitute 2 into there. That's given to me by this, right? The 2 is given to me. So it's 2/3 h, which is 2 minus 2. Okay. Then, so that 2 times 2 is 4 over 3 minus 2. this would be the same thing as 4/3 minus 2 times 3 is 6. So it's 6 over 2, 6 over 3 at my bad, right? Because this is still 2. That's my trick always. I multiply to get the 6 and then just make it out of 3, and that is essentially the same, right? So 4 minus 2, that's negative 2/3. So g of 2 is negative 2/3. That's the output. When you plug in 2 into that function, you would get negative 2/3 out of that. Okay. Another one, and this is backwards. You're trying to figure out what was plugged in here to get an output of negative 5. Okay, so this would be our x, this would be our function, or g, sorry. They're using g for the letter of the function. And you get g of x here. Okay, and we need to figure out what it was. So what you do here is, knowing that g of x, which is unknown, is negative 3x minus 1. So I'm going to start off with exactly what I had up here. In this case, I know g of x. I know this. The output is given. So I go negative 5 is equal to negative 3x minus 1. Now we have to isolate x. That's basically what you have to do here. So we've kind of done this already with the surface area and volume, right? When you work backwards, when you use an algebraic method to figure out the unknown, the radius, the height, you name it. So what we need to do first here is, I like to sometimes think of things just changing signs when they come over. I don't know if you were ever taught that, but the negative 1 comes over, so it's negative 5 plus 1. When it comes over the equal sign, it changes the sign like that. So you have that be negative 4 is equal to negative 3x. And now we need to divide both sides by negative 3. So when you're multiplying and dividing, you don't do the sign change thing. It's just when you're bringing stuff over, when you're bringing terms over, when you're adding and subtracting, essentially. Some of you will have learned to just add 1 to both sides to cancel this out. You get the same thing. This cancels out. This gives you a positive 4 over 3. And keep them in fractions. Do not turn them into decimals, right? It has to be simplified, but that's about it. Okay, let's keep going. Okay, so we're going to use some function notation here. So we're going to apply what we just learned to different situations including word problems, okay? Carmen works for a research company in a shopping mall. The equation P is equal to 5n plus 30 represents her daily pay, P in dollars, when she conducts n number of surveys. Describe the function. Write the equation using function notation. How about we write it using function notation first of all? If you have P here and an N there, the way you turn that into a function notation is to say P in terms of N is going to be 5N plus 30. So how would you describe this? How would you describe this function, like within the context that's happening here? Carmen gets paid $5 per survey. I think I should have worded this differently. She gets paid $30 flat, right, for doing the work, and then on top of that, she gets $5 per survey. But it's still okay. Carmen gets paid $5 per survey plus a $30 flat fee. Okay, So she gets $30 and then $5 per survey thereafter, right? Just a bit of an incentive. And if there had been no word problem, you would just say N gets multiplied by 5 and then added to 30. That result gets added to 30. This is the word problem, right? Within a context, right? And no context would just be N gets multiplied by 5, then gets added to 30. That answer gets added to 30. Okay, just be specific there. Find the value of P8. What does this number represent? So we're going to go P8 represents 5 times 8. So wherever there's an N, we're going to put an 8 plus 30. This is 40 plus 30. And this is 70. And remember, P, right? This whole thing is your pay in dollars. So that's what you're finding. Okay. What does this number represent? It represents the pay, Carmen's pay for conducting 5 surveys. 8 surveys. That's what it represents. It represents her pay. Okay. And here they kind of specified what we're doing here. Find the value of N when Pn is equal to 90, right? So they're basically, if you start off with this again, Pn is 90, right? So we're going to substitute 90 in there and then essentially isolate N. And these types of questions, right now, there are no fractions just yet. So it's actually pretty straightforward. The 30 comes over subtracting, leaving you with 5n on this side. That gives you 60 is equal to 5n. Divide both sides by 5. And remember, you have your calculator, but it really doesn't help you a whole lot here. And that would be 12, right? N is equal to 12. After performing 12 surveys, comma, Carmen gets paid $90. So just look at what the context represents and try to explain what it is that you solved, okay? So this is, here we have fractional. Fractional equations. This is the short for equations. Equation or equations, okay? So we're gonna do that here. So when I assign from this section, come back to these pages to help you out. Okay, so here we have find x if f of x is 8. So basically you're isolating for x here. So this is given to you. So you just replace that with the value, and that's 2/3 x minus 4. And here I'll just tell you the same thing. Always get rid of the thing that's adding or subtracting to x. The multiplying and dividing, you take care of that later. And so you're going to add, right? The 4 is going to come over adding like that. That's 12 is equal to 2/3 x. We're going to multiply both sides by 3. That cancels out this to get 36 is equal to 2x. Now you're going to divide both sides by 2 to cancel out. And so that gives you 18. Okay, you got 18 there. I'm tempted to do the, if you're a rebel and you forget to do what I just did to first bring the 4 over, then I will show you what's going to happen. So let's say it's like, hey, I want to get rid of that 3. Then that means you have to multiply everything by 3, the whole side by 3. 3 times 8 is 24. 3 times 2 is 6, divided by 3 is just 2, right? So you end up with 2x, that's good, minus 12. Okay, so then you bring the 12 over, adding is equal to 2x. So you see that you end up with the same as long as you're consistent. X is equal to 18. So same thing, you just got to be very careful. I would prefer preferred method. My preferred method. And it will, over the long run, save you a lot of grief, okay? And determine the value of f of x if x is equal to 1/2. What's f of x? That's this function right here. We're referring to, that's the name we give this function, okay? So we will find what f of x is, given that this is 2/3, x is equal to 1/2 minus 4. So here, no isolating required. You just have to compute and do your arithmetic here. 1 times 2 is 2, 3 times 2 is 6, minus 4. You could have actually canceled out 1 and 1, right? 2 goes in here once and goes in there once, but it is what it is. I'll reduce this first, 1 over 3, right? 2 goes in there once, 2 goes in there 3 times, minus 4. Look at my trick, 3 times 4 is 12 over 3, and then you still have 1 minus 12/3. 1/3 minus 12/3 is negative 11/3. And so that's what f of x is equal to, negative 11/3. So you just got to be careful there, okay? All right, now I want you to try. You try. And you will be doing all of this, okay? This whole page here, all the way to the bottom, as well as this next page, which has some fractional notations. Do this on loose leaf to have enough room. And all of the answers, this is from the first page, right? These two are the first page that I just assigned, and these are the answers to these questions up here, the fractional ones. So you need to be really good at that. It'll make your life a lot easier as we move forward in the units to come. So make sure you practice this and show proper steps and notations, okay? And that'll be it for today's lesson. So this is your homework in a sense for this, okay? Have a good one.